Okay, we're going to take a look at trig ratios on the Cartesian plane. Now, some of the background for this is that most of us have already got an idea of when we see a right triangle and an angle theta down in here, we already know what the trig function is. So I've got my opposite side over here, I've got my adjacent side here, and I've got my hypotenuse here. Okay, and the little acronym that we use to remember those looks like this, right? So my sine of theta is going to be the opposite over the hypotenuse. My cos of theta is going to equal my adjacent over my hypotenuse. And tan of theta, tangent of theta, is going to be the opposite over the adjacent. Opposite over the adjacent. Okay. So now all we're going to do is and the reciprocals that go with it. Okay. All we're going to do now is we're going to take that triangle and we're going to plop it onto the Cartesian plane and find out what these angles are in terms of x and y. So when I put a point on the graph here, P, X, Y, what I can build is a right triangle. If I drop down a distance of, that distance from here to here is going to be y, because I've got a little, right? This is y from here to here, this is y from there to there. And I've got a distance of x out to here, right? So this distance is x, and this distance is y. Okay, and that's my right triangle. So my y is kind of linked up to my opposite side here, and my x is my adjacent side. So we're just going to go and rewrite these trig functions in terms of x and y. Okay, so I'm going to you guys have the note below here that's going to do. I'm just going to write them on the side so we can see what's going on here. So now my sine of theta is going to equal my opposite over my hypotenuse is now y over r. And my cos theta is equal to my adjacent over my hypotenuse, or my x over my r, over my radius, right? Okay, and tan is opposite over adjacent, so my y over my x. And now my reciprocal trig functions, with sine goes cosecant theta, and I'm just going to flip it. It's going to be r over y. My secant theta is going to be r over x, and my cotangent theta is going to be x over y. So let's go ahead and put those to work here. Okay, so there's a place where you can fill in the note. But here's a couple of examples. So let's start with this one. Right, so it says the terminal side theta in a standard position passes through point P. Draw theta and find the exact value of all 6 trig functions of theta. So let's draw our point P. So it looks like x is 6. So draw out 6 here. And y is 8. Draw out 8 there. Oops, a little crazy. And so there's our point, P. So we're going to go ahead and draw our angle. Our radius goes out here. That's our point 0.68. And now I'm going to draw my right triangle. Okay. So if y is 8 from here to here, that means that this side of my right triangle, so here's my angle theta in there, this y is 8 high, and this x is 6 long. So the distance from here to here is 6. Okay. So by using our Pythagorean theorem, we can go ahead and find we want all 6 trig functions, so we're going to need y, x, and the radius. So let's go find the radius first. Okay, and this is a nice example of a kind of a special triangle. I can see 6 and 8 both have a factor of 2 in it. Right? 8 is equal to 4 times 2, and 6 is equal to 3 times 2. And so up here, if I see a 3 and a 4 in a right triangle, it's one of those special 3, 4, 5 triangles. Okay, so this side, if this is 3 times 2, this is 4 times 2, this side must be 5 times 2, or 10. Okay, but that doesn't even really matter because we're looking at ratios from side to side. So if I'm dealing with similar triangles, okay, those ratios are going to hold. So I can use the 3, 4, 5 ratio for all of my trig functions. Okay, because let's do this one. Let's do sine of theta. Okay, so sine theta is going to equal my y over my r. Okay, so it's going to equal 8 over 10. Okay, which is really equal to 4 over 5. So I could have just said 4 over 5 in the first place. My cos of theta is going to be my x over my r, or 6 over 10, or simply reduce 3 over 5. Tan theta is going to be my y over my x, which is the same as 4 over 3. And then we can do the reciprocals. So cosecant theta is the reciprocal of sine. So I know that that one's going to be 5 over 4. Secant theta is the reciprocal of cos theta. So this one's going to be 5 over 3. And cotangent theta, the reciprocal of tan, that measure is going to be, that trig ratio is going to be 3 over 4. So that's kind of a simple example. Let's try something a little bit more fun. This one is not in our first quadrant. So let's see what this one pans out like. So I've got a minus 4 here. Ooh, and the root sign, scary. Height of root of 2 here. And we want to find those 6 trig functions. So we're going to draw a right triangle again. Let's see if I can make this look halfway as neat. Okay, so there's our point P at minus 4 and plus root of 2. So I know this distance is root of 2. And this distance over here is actually a negative 4, right? So let's go ahead and find our trig functions, or our trig ratios for this angle, theta. But before we do that, I guess we got to go and take a look at what this side is. So I'm going to use a Pythagorean theorem here and say that root of 2 all squared plus negative 4 all squared is going to equal my radius squared. So my radius squared looks like it's going to be 2 plus 16. My radius, take the square root of both sides, is going to be the square root of 18, which can be reduced to 3 root 2. Okay, so let's go and find our trig functions now. So sine of theta is going to equal my y over my r. So y over r gives me root of 2 over 3 roots of 2. And that simplifies out. Look at this. Nice. That's pretty. So root of 2 over 2 over root of 2 is 1. So sine theta is equal to a third. So I guess that's going to make the cosecant theta, its reciprocal, 3. Okay. Cos theta is going to equal x over r. So that's going to be minus 4 over 3 roots of 2. And now we want to do a little simplification here. We're going to get rid of the root sign by rationalizing. So I'm going to multiply by a really convenient 1, root of 2 over root of 2. So I haven't changed the value there at all. And that's going to turn out to be minus 4 roots of 2 over 3 times 2 is 6. Okay, and I can reduce that one more time. Looks like I got a 2 here and a 2 here. So that's going to give me 2 roots of minus 2 roots of 2 over 3. Okay, now the reciprocal of that is going to be your secant theta, which is equal to 3 over negative 2 roots of 2. So again, we want to rationalize. So root of 2 on top, root of 2 on the bottom. So a convenient 1 gives me negative, doesn't matter where the negative goes, right? This whole number is negative, negative 3 roots of 2 all over 2 times 2 sounds like 4. Okay. And finally, let's do tan theta. And it's going to equal our opposite over our adjacent side, so root of 2 over negative 4. So that means that the cotangent of theta is going to equal negative 4 over root of 2. Rationalize that puppy out, and I get negative 4 roots of 2 over 2, and finally negative 2 roots of... Alright, so let's rip through another example here. They're getting a little tougher each time. So let's go, this time they're giving me the trig ratio with the angle and a place to find our solution, where they want those trig angles to be. Okay, so we know our solution is going to be in this quadrant in between 3 pi over 2 and 2 pi, right? And I also know that my sine ratio is y over r, so my 5 must be this distance, a negative 5 here, and because my radius always has to be positive, I know I've got a distance of 13 out here. Okay, so I'm looking for, I've got 5 out here, I know my hypotenuse is 13, and what I'd like to know is this distance here. But this is really, so this is minus 5, but this is one of our special triangles, right? Okay, if this one's 5, the hypotenuse is 13, my other side is 12. Okay, so now we've got all 3 sides of our triangle, so we can go and find all the trig functions. So we already know sine, so with sine goes cosecant theta. It's going to be reciprocal of that, or minus 13 over 5. Okay, the cos of theta, okay, so this is theta in here, right? Cos of theta is going to be my adjacent over my hypotenuse, which is going to be a positive 12 over 13. This is positive 12 over 13, and so that means that my secant theta is going to be 13 over 12, and the ratio for my tangent of theta is going to equal my opposite over my adjacent side, which is going to be negative 5 over 12, which makes my cotangent of theta minus 12 over 5. So it looks like we're doing the same thing in each question here. Okay, looks like we're going and we're finding out where our triangle is going to be on our plane. So this one's telling us it's in between pi and 2 pi, so it's going to be in one of these 2 quadrants. And then we use our ratio from the trig function to map out where it's supposed to be. So here we're going to get minus 2 over 1. That's going to be my r over x, right? It's secant, so my ratio is r over x. So I see this minus sign here, and because I know my radius always has to be positive, it means that my minus sign really belongs to the 1. So I'm going to map in minus 1 here for x. I know my radius has to be 2, so now I've got to find out what this y distance is. So I'm going to use the Pythagorean theorem and say that r squared is equal to x squared plus y squared. And so here I'm going to have 4 is equal to negative 1 squared is 1 plus y squared. So it looks like y is going to be the square root of 3. Okay, but it has to be a negative square root of 3 because I'm in this quadrant. These are negative distances here, so I know that in this quadrant it's going to be minus square root of 3. So I'm working with that angle. Okay, so I'm going to leave the rest for you as an exercise there. Like I've got my 3 parts. I've got negative 1 here, negative root of 3, and 2, and you guys can find out the trig functions, and that should do you for next time.